Okay, in this podcast we're talking about molality, which is a little different than molarity. First of all, the symbol is a small m instead of a capital M. And we're talking about, we're still talking about the moles of solute, but this time we're talking about per kilogram of solvent. Remember, for molarity, for big M, it was per liter of solution. So we're talking about kilograms instead of liters, and we're talking about the solvent instead of the solution. Okay, so why would we want to use units of molality instead of molarity? Well, we do when there's extremes of temperature involved, and that's because the liter's volume can change with temperature. It doesn't change very much with a liquid, but it can change slightly, so we want to really look at exactly how many moles there are per kilogram without being worried about the volume varying. Okay, so we'll see in the next topic we'll talk about extremes of temperature, and that's why we want to use molality. Okay, so let's go ahead and take a look at a problem. Alright, so here we have a solution was prepared by dissolving 17.1 grams of sugar in 125 grams of water, and we want to find the molal concentration. Okay, so we have So first of all, the formula is, let's just get this up. The formula for molality equals moles of solute over kilograms of solvent. Okay, and we don't have moles yet, but we do know kilograms, which is going to be that divided by 1,000, 0.125 kilograms of water. Okay, so let's find the number of moles, 17.1 grams, and I'm just going to call it sugar. And I found the molar mass, which is 342.34 grams of sugar is 1 mole of sugar, and this gives us 0.0500 moles of sugar. I'm going to put that up here. And if I divide those, I'm going to get 0.400 moles per kilogram of sugar. But moles per kilogram I can abbreviate as molal, 0.400 m of sugar. So that's 0.400 molal sugar. Let's try another. Here I want to know how many grams of methanol is needed to prepare a 0.244 molal solution of methanol in 400 grams of water. So we're going to again start off with the formula, and the formula for molality is M equals moles over kilogram. So what we know is molality is 0.244 m. Okay, we don't know moles yet. We do know kilograms, it's 0.400. Okay, so I can get moles by multiplying my molality times my kilograms. So moles is going to be 0.244 times 400, which will give me 0.0976 moles of CH3OH. Okay, but it's asking for grams, so I've got to convert this to grams. What I know is 1 mole of methanol is, let me see, 32.05 grams. So this is going to give me grams of 3.13 grams of methanol. Okay, let's try another problem. In this one we want to know how many grams of water should be added to 15 grams of sodium chloride to prepare a 0.10 molal solution. So what we want to do, again, we've got the molality equation. Molality is moles over kilograms. In this case I'm trying to find kilograms. So let's first change the equation to solve for kilograms. So this times this, as you know, cross multiply is going to be that times 1, right? So molality times kilograms is moles. If I want to get kilograms by itself, I divide both sides by molality. So kilograms is going to be my number of moles divided by molality. Okay? So I know my molality, it tells me it right here, 0.100 molal. But let's find the moles. I have 15.0 grams of sodium chloride, and I know 1 mole of sodium chloride is 58.44 grams of sodium chloride, and this is going to be 0.257 moles. Okay, so if I divide by 2.257 moles divided by 0.1 molal, I get 2.57, and this is kilograms. It wants to know how many grams. I can just multiply that times 1,000, and I get 2,570 grams. Okay, that's going to do it for us.